Hello everyone, today we're going to talk about characteristics of a quadratic function. And we're going to kind of start with the parent function, f of x is equal to x squared, and we're going to find all of these characteristics for that function. So the first thing we're going to talk about is domain, okay? And whenever we're talking about the domain of a function, we're always going to look at our graph, and we are going to read from left to right. And when I'm describing domain, what I'm going to do is I'm going to describe all x values of the function. Okay, and all x values of the function are describing how far this thing is going to the left, how far it's going to the right. So if we zoom out a little bit so we can see this function, notice that this thing actually never stops going to the left. So right here, we can see that we're actually going to put some arrows in the end of this thing, and it never stops going to the left, and it never stops going to the right. So one way that I could write the domain of this function would be to say that the domain of this thing is all real numbers. Okay, you might also see this written as going from negative infinity until positive infinity. That's a couple different representations that you might see here. So we're just saying that it starts at negative infinity on the left side, and then it goes all the way to positive infinity to the right side. So either of these answers right here would be right for the domain, okay? Next thing we're gonna talk about is the range, okay? And what the range does is it describes all the y values. And since y values go up and down, we're gonna read from bottom to top. And what we're doing is we're describing all y values. So if we take a look at this function that we have here, if I'm trying to describe all the y values that we have here, the lowest y value that we see is 0. And then we notice that it never stops going up. So I would say that the y values of this thing, they go from, I could use interval notation and say that they go from 0, and then we're actually going to have a bracket there because it touches 0 to infinity, okay? I could also use inequality notation, and I could say it this way: y is greater than or equal to 0. Both of those things mean the same thing, and they describe the range of this function. Okay, next characteristic we're going to look at is the direction, and we're just trying to describe, is this thing opening up? Is it opening down? Okay, so we're trying to describe the direction that the value is pointing. Okay, and we can see it, this graph, it is pointing up, okay? And if I look at the function, if I just have f of x is x squared, there's no negative in front of it. It's always going to be pointing up. If there were a negative right here, it would be going down. And we're describing, is it going up? Is it going down? That's what direction is, okay? In behavior, the next thing, we're going to describe what's happening on the left and right side. Okay, so if I were to imagine that I was standing in the middle of this function, I was standing right here, okay, and I look to the left, what's happening is this function is rising, okay? Then also, if I stand in the middle and I look to the right, again, this function is rising. So we're gonna say this thing rises on the left and it rises on the right. And that's all in behavior is. You're describing what's happening on each side of the graph, okay? Next thing, max or min. A quadratic function is always going to have either a maximum or a minimum value, okay? So we're just describing how low or high the function goes. So for this function that we have right here, we notice that the lowest point is right here, and it's always the vertex, okay? And the y value of that vertex is 0, so this function would have a minimum, and that minimum is 0. Okay, and we're just describing the y value of that minimum or the maximum, okay? The next two intervals of increase and decrease, we are going to read this thing from left to right again, okay? And we want to describe when it's going up and when it's going down, okay? And the thing to remember here is you're always going to use x values, okay? So if I wanted to read this thing from left to right, and I like to say that I'm pretending that I'm on a roller coaster. If I start on the left side, okay, right here, this thing is going down, okay? And it doesn't stop going down until we get to the vertex. So if I'm only using x values, so if I go way over here, if I go as far as I can actually go to negative infinity. My x value over here is negative infinity. And it stops at 0. And that would actually be my interval of decrease. So from negative infinity to 0 would be an interval of decrease here. An interval of increase is actually going to start at 0, okay? And then after I pass 0, it's never going to stop increasing. It's going to increase forever. So it would go all the way to positive infinity. So that would be my interval of increase, okay? Next thing, x-intercept. I can always find the x-intercept by setting the function equal to 0 and solving. Okay, so this one we're going to get, and we can actually kind of look at the graph here. We can see that touches the x-axis right here at the point 0, 0. Okay, sometimes I'm not going to be able to see that clearly on the graph, so I'm going to have to solve for it. But this one will be 0, 0. And something to remember here is that we could have 0, 1, or there could be two different x-intercepts. And the last thing, the y-intercept, we are going to substitute 0 for x and simplify. And then, so this equation right here, if I substitute 0 for x, it's just x squared, so 0 squared is 0. So again, my y-intercept is also the point 0, 0. And then there will always be 1 and just 1 y-intercept. Okay, so those are all of our characteristics, and those are what we should be able to find today, and that's what we'll work on today, is finding these characteristics of quadratic functions. So let's take a look at one example. So right here, I have this equation, and I want to find all the characteristics of it that we see over here on the left side. So first thing we're going to do, let's kind of start with the first few. The vertex, we know how to find that. We found that last week. Vertex of this thing is going to be 2, 1. Okay, axis of symmetry, did that last week as well. It's going to be the x value of this vertex, x equal to 2. And then since we have this negative in front, this thing is going to open down. Okay, so let's kind of use that to help us create a graph of this thing. So we're going to draw a table just like we did last week. All right, 2, 1 is going to be in the middle of that table, and I'm going to pick numbers on each side of 2. So if I substitute 0 in, that is going to give me -3. If I substitute 1 in, that's actually going to give me 0. 3 is also going to give me 0, and 4 is going to be -3. So here are my points, 0, -3, 2, or 1, 0, 2, 1, 3, 0, and 4, -3. And that creates this graph. So that's our quadratic function, all right? For the domain, that's always going to be all real numbers. For every quadratic function that we look at here, it's going to be all real numbers. Our range is going to be y is less than or equal to 1. X-intercepts, I can actually see those in my table because I have zeros in the table here. It's 1, 0, and 3, 0. Okay, the y-intercept is also in my table this time. It's 0, 3 right there because I plugged 0 in for y already. So I have the point 0, 3. And then interval of increase and decrease. Remember, we're going to read this thing from left to right. So if I start on the left side, we're going up. So we started way over here at -infinity, and we're actually going to stop when x is 2. So that's an interval of increase. Started at -infinity, and it stops at 2. After I pass 2, what happens is we're going to decrease for infinity and beyond. So it started at 2, and it goes forever all the way to positive infinity. That's our interval of decrease, okay? This thing is going to have a maximum value because it has a highest point, and that maximum value is 1. And then our end behavior, notice that if I stand in the middle of this thing and I look to the left, it's falling, and I look to the right, it's also falling. So we're going to say this thing falls on the left, and it falls on the right. And that's it. That's all of our characteristics. So let's do another one here, starting with vertex. So we know that our vertex is at the point for -1. Axis of symmetry, x is equal to 4. Direction, this thing is going to open up. Okay, so let's create our graph here. So I know that 4, -1 is going to be in the middle. And then let's say 2, 3, 5, and 6. Those are other x values that I want to use. So I substitute 2 in, and that's going to be 7. I substitute 3 in, that's going to be 1, and then also 1 and 7. So let's graph this thing. So 2, 7 is going to be right there. 3, 1 is going to be here. 4, negative 1 will be here. 5, 1, and 6, 7 be over here. So when we connect this thing, it's going to look like that. Okay, so our domain is going to be all real numbers. Range, the lowest y value is negative 1. So I could say that y is greater than or equal to negative 1. X-intercepts. So we see that there are 2 x-intercepts, but we don't know exactly where they are. We actually have to solve for those. So here's what we're going to do. We're going to set this thing equal to 0. So I have 2 times x minus 4 squared minus 1 equal to 0 and solve. So we're going to add 1 to both sides. That's going to give me 2 times x minus 4 squared is equal to 1. We're going to divide by 2, so that's going to give me x minus 4 squared is equal to 1/2. Take the square root of both. X minus 4 is equal to plus or minus root 1/2. And then add 4 to both sides. So x is equal to 4 plus or minus root 1/2. But we want to get a better idea of where these are in the graph. So we're actually going to find the decimal approximation for these. So I've got 4 plus root 1/2 and 4 minus root 1/2. So 4 plus the square root of 1/2 is that's going to be about 4.7. And then 4 minus root 1/2 is about 3.3. Okay, so my x-intercepts are the points 4.7 comma 0 and 3.3 comma 0. Okay, y-intercept, we're going to substitute 0 in. So we have 2 times 0 minus 4 squared minus 1. Okay, so that's going to be 4 squared is 16. 16 times 2 is 32, so we have 31. So when x is 0, y is 31. That is the y-intercept of this thing, which makes sense because it's going to keep going up. So I expect it to cross the y-axis somewhere way up there. Okay. Intervals of increase and decrease. This thing is going to increase from 4 to infinity. And it's going to decrease from negative infinity to 4. This thing has a minimum value, and that minimum value is negative 1. And this thing rises on the left, and it rises on the right. So that's it. So today you should be able to find characteristics of quadratic functions. So please go check out the assignment on Canvas. Let me know if you have any questions. Have a great day.